Today we're going to talk about making your own ERC20 token. So Ethereum is a blockchain-based computer. The idea with Bitcoin was that there was a ledger, and the magic of the blockchain allowed everyone participating in the network to agree on the state of the ledger. That is, how much money was in each wallet. The same technology used there, there are some details different, but the main idea is the same, allowed the Ethereum guys to let computers agree on the state of a virtual machine. So there's the Ethereum virtual machine. It has opcodes and instructions, and then the events that come into it you can think of as being analogous to keyboard inputs or mouse movements or network events. All these kind of external things to the computer happen, and then all of the machines participating in the network have to agree in what order they're going to be considered to have happened. So with Ethereum transactions, you can say something like, Alice needs to pay Dave, so send some money over there. Carol pays Bob, send some money this way. But then the Ethereum network has to decide whether Alice paid Dave first or Carol paid Bob first. The notion of money on the Ethereum network is called ERC20. ERC20 is an interface that smart contracts have to implement in order to keep track of balances, to transfer things around. All that sort of stuff is wrapped up in this interface, and so implementations of the ERC20 contract are what we usually call tokens. So an ERC20 token. The software we're going to use today needs Node for the local simulation of the Ethereum network. So I'm not going to connect to an actual Ethereum network and deploy an actual contract. I'm going to run something here called Ganache CLI. And when I run this, there it goes, it starts up and creates 10 accounts that you can use for playing around with and lists their associated private keys here. So I'm going to copy this stuff out into a document for easy access. Let me get it started. You can find the Ganache CLI on GitHub under Truffle Suite. It's like the chocolate or the mushroom truffle suite. Ganache-CLI. The next site we're going to use is the Solidity online compiler. Now the problem with this is that it's beta software. It's not very stable. So this tab often dies. That said, it is the most convenient way of working with this stuff. The Solidity Compiler lets you manage a set of files here. We're just going to use one. Oh, it's grinding away as it's compiling. When you first load up the page, it does a compilation, so we have to wait for this to keep it from dying. One more time. There we go. So this particular file has a bunch of warnings here. They're mostly about the fact that it's older code, that there's some deprecated things going on there. But it's reasonable code. The other one here says that you can mark it as pure functional, and that gives it a little boost in the compiler. But there are no errors here. The third bit of software we're going to be using is the Gnosis wallet page. So this tracks wallets, and right now can see up here at the top, there are there's no information about accounts or anything. To work with both the Solidity Compiler and the Gnosis Wallet page, we're going to install a Chrome extension called MetaMask. It's this Fox guy here. Add to Chrome. Close that. So now we have a little fox up here in the corner. There's some other web pages that pop up automatically. We don't need them. When you click on the fox, pops up here, gives you a warning that it's beta software. Everything about cryptocurrency is still brand new. There's end user license. Accept that. Create a new password. And then it gives you a 12-word phrase. Now I'm not going to copy this down because this is a very temporary one, but these 12 words you print out on a sheet of paper, you go to your bank and you put it in a security deposit box, because that is how you're going to manage all of the funds that you're dealing with. Copied it somewhere safe. Now it shows this account. Up here at the top, main network. It's hard to read here, but it says main network. This is connected at the moment to the main Ethereum network, but if we click on it, we get various options. There's a main Ethereum network, and then 3 really popular test networks, and then localhost 8545. This is where the Ganache CLI is running. So we're going to connect to that eventually. To save some crud being written to the thing, I won't do it just yet. But we go back over here to our accounts page, grab a private key, return here, MetaMask, click on this head with some arrows going around it, and say import account. Private key, then we just paste it there, import. So there we have a new account. Click on the edit thing at the top. I'm going to name it after me. There we go. And just to get something convenient here, demonstrate multisig wallets, we're going to do it a couple more times. Create account. Oops, not that one. Import account. Name this one Alice. Last one. Import account. Name this guy Bob. All right. So now this extension is injecting into every page you visit once you've logged in information about the Ethereum network you're connected to, the account that you're currently logged into, and tracks all the transactions that this account has done, as well as which tokens this account has and what their balances are. So right now there's none of that going on. But I'm going to switch here to localhost 8545, and you see that now Bob has 100 Ethereum. So every one of these sample tokens is created with 100 Ethereum. I'm going to switch back to the one named Mike Stay. When we come over here to this Multisig Wallet, we can reload the page. And it shows that Now there's this account number here and a balance. When we click Add Wallet Now, we can create a new wallet. And this one I'm going to do is a multisig wallet. So I'm going to call it multisig. Going to require 2 out of 3 to confirm it. If you leave the daily limit at 0, then there's no restrictions on how much can move around. And automatically, I am one of the owners on this account. So then I can go up here or back to my list. So Mike Stay is the top one. Alice here is this one. So I can copy this out. Stick the address in. Alice. Stick this one in. Bob. And deploy. This is just asking how much you want to pay for the deployment of this wallet. It says, I'm willing to spend 3 million gas at 1 gigaway per unit of gas and pay this much in transaction fees. And you can alter that if you want to. It doesn't matter in this case because I'm running my own little personal network. It'll automatically run all that for me. When you hit send, the MetaMask extension here intercepts that send and says, are you sure you really want to do this? So that some website can't automatically send stuff on your behalf. It always intercepts it and makes you double check it. So we say submit. So the deployment transaction was sent, we wait, wallet is deployed. Now it appears here. We have an address for the wallet. We can click on multisig and see all the transactions of the wallet. Now there are no tokens in it yet. And once we create our ERC20 token, it'll appear here and we can track what's going on with that. So go back to the Solidity IDE. This is the let's see, try and zoom in a little bit here and stretch it out so we can see better. This is a contract that I grabbed off the internet somewhere. There are lots of different features that a token can have. They all have to implement the ERC20 contract, but there are other things that you want. This ownable contract means that you can transfer a contract to some other owner who can then delete it later. Safe math is one of the critical things. So because Ethereum was pretty much an experiment that took off far beyond its creators' dreams, they defined this machine without all of the checks that you might expect. So it suffers from overflow, underflow problems, those sorts of things. So when you want to use math functions in your contract for debiting an account, you don't want to debit it and then have an underflow and suddenly have 2 to the 64th of your token sitting around magically. So these things check that either A is 0 or C divided by A is B once you've done the multiplication. So if there's any round off errors, any of that sort of stuff, this will throw an exception. Similarly for division, subtraction, B has to be less than or equal to A when you're subtracting, and so on. This is a very critical part of any ERC contract that you're going to write. These are the basic methods in the ERC contract. We've got a total supply of coins or tokens. You can ask the balance of some individual's address. You can transfer stuff between people. This is an event that fires whenever a transfer occurs. Here's an allowance, so you can allow someone else to transfer a certain amount of money out of the thing from your one to theirs. That's how you do payment, is giving them an allowance. They are allowed to transfer from your address to theirs. You can approve transactions on Multisig Wallet's approval, that sort of thing. Here's a basic token with an implementation of those things. So here's how to transfer, how to get the balance. More implementation. Standard token implements both the ERC20 and the basic token contract. And in the end, there's a mintable token that you can create. And right down here at the bottom is the stuff that's specific to the token we're creating. So naming this one my token, MTKN. These are pretty arbitrary. Total supply. Oh, I'm sorry. I updated that. There we go. There we go. I guess I named this one Mike token. Here's one with 15 zeros after it. So the 15 decimal digits there are the total number of digits. But we're also saying that the decimal point is 6 places to the left of that. So we can divide each token into millionths, and we have a billion in all of them. So 6 decimal places, 9 for the total number of zeros deployed, and the initial balance here, I just put in some big number that gave that much to the deployer of the contract. Oop. So, in this case, I think I'm going to give all of the money to the deployer of the contract. There we go. I'm going to shrink this a little bit. And open up this side panel. So at the top we see compile. This will tell you what's going on. Run is the next one you want to look at. There are various other things for debugging your contract and analysis, figuring out where things go wrong, various settings you might want to change. The Run tab here is using a JavaScript VM at the moment. What we want is a Web3 provider. You click OK and choose localhost 8545 for where to connect to. Click OK. Then it immediately grabs my account number here from that. Let's see. I think it may need to recompile. Expected. Oh, there's an equals at the top. I hit accidentally while zooming out. There we go. Okay, so it's recompiled. Go back to the run place here. Now we have a choice of which of these various things defined in this file to deploy. We're going to choose my token and then hit the create button. Have to wait a little bit. Great, so now it has been deployed, and we can hit this copy icon to grab the address of the token. Successfully copied. Now I can go back up here and I can add this token here. So when I paste it in, it automatically pulls up the token symbol and the number decimals of precision. Hit add, loads, Now I have a lot of mics. Yay! This is...
Can I buy into your ICO?
Sure, I'll sell them for a cent a piece and be very happy with the outcome. So once I've got tokens, I can go back over here to the Multisig Wallet, add the token, paste it in again. It derives the stuff. You click OK. And then says, I have 100 million mics. The wallet doesn't have any yet. So I can deposit some into there. Now that's probably the first thing you want to do if you don't want people coming after you with a rubber hose, right, is to make a multi-sig wallet and put all of your coins in there so that it takes at least a few people to approve this. So I'm going to put all of it in there, send the transaction, just choose the defaults, pops up with the intercepted one. Approve that. You get a little notification that it was sent. And then the green one saying it was received. Now, on the actual Ethereum network, this can take, depending on how much in transaction fees you're supplying and how much you're willing to pay for gas, that could take minutes to hours. Maybe never even get in if you're not willing to pay enough. So you can look. Let's see. There is a site where you can find the current. How much people are currently paying for gas, so you bid appropriately, but I can't remember what that is offhand right now. I'm sure you can Google it and find out. But now we see that all 100 million of them show up here in the multi-sig balance. So now when it comes time to withdraw, say I want to pull out 10 of them for me, send the transaction, approve it, get a withdraw transaction sent, and then shortly here we should see the green. There it is. Down here at the bottom we see a transfer to transfer 10 mic to my account. Here I can say no, don't do that anymore before anyone else sees it. Now somebody else has to approve this, right? Because we needed 2 out of the 3 to approve it. So I'm going to switch here over to Alice's account. When I did that, the account number changed up here. Oops. Shows her with 100 ETH, because she hasn't spent any of it on transactions yet. And now instead of the revoke, she's got this confirm button that allows her to hit that and say, yes, I approve this transfer to Mike. So you hit the confirm button, send the transaction. Submit. Confirmation sent and confirmation received. So then this shows up as having the 2 confirmations and having been executed. We can switch back to my view instead of Alice's. Switches, updates the page. Great. So now it shows that there are 99,999,990 of them in the wallet and 10 in my account. And that's how it works. So this is exactly the process we went through when creating our Spark token that we recently exchanged for rocks with our chain. This is fairly straightforward. Now, all of you can go out and create your own ERC20 contract and start your own ICOs.